Okay, we are going to discuss Newton's method. Which is one of many methods that we have for approximating equations by now. I mean, we have the rule of double false position. We have the method of Vieta. This is another way we can approximate solutions to anything that we can take the derivative of, in fact. But let's do something relatively simple. Let's try something like x squared plus 4x minus 6. So what we're going to do is we're going to start off with an initial guess. Let's try x naught equals 1. That's a nice guess to something like this, because we get 5 minus 6, which is minus 1, which is not that far away from 0. I mean, we could be farther. So let's try to see what happens if I rewrite this formula first by including the function and its derivative. Of course, hopefully we all know what the derivative is of a quadratic. It's going to give us 2x plus 4. So if I take x naught equal to 1, I get 1 minus, well, this is going to be 1 plus 4, which is going to be 5 minus 6. So minus 1. And then I plug 1 in here, and I get 6. So I get 1 plus 1, 6. Which, if you guys recall, is the same approximation that we got using a different method. Actually, Vieta's method earlier, and another one of the integrity sessions. But the nice thing here is, well, let's see. We could go further with Vieta's method, or we could have gone further with Vieta's method. But in this, it's well, it's quite fast. We have a formula. Should have been x naughts. And we can keep going very easily. See, this formula doesn't only work when you're dealing with x naught and x1. In general, we can get xn plus 1 by taking xn and subtracting f of xn over f prime of xn. So in general, if we wanted to get, well, let's specify to the case that we just had xn. So I believe our polynomial was xn squared minus 4x, no, it was plus 4x minus 6, and that's an xn. And I get 2xn plus 4 down here for the derivative. And I can plug then our x1 was 7, 6. I can plug that in here. So I get 7, 6 minus, well, this is going to be 49, 36, plus 4 times 7, 4 times 7 is 28, over 6 minus 6. So this is 2 times 7, 6, plus 4, which wouldn't be too hard to simplify if I had a little more room on my screen. But let's try to see what we can do. And to not make any mistakes, I'm going to pull out my calculator just to check. So 28 times 6, you guys are probably all done. 168 over 36, and of course minus, well, 6 times 36 is 216. And then I get 14 over 6 plus 24 over 6. So what I can do now is, well, I can just enter this all into the calculator here. I mean, multiply the top and the bottom by 36 and you get 49 plus 168 minus 216. So that is going to give me 1. And then I get 14 plus 24 times 6. Over 228. So our x2 is going to be, of course there's a 7/6 right there. So 7/6 minus 1 over 228. And we can keep going, though the fractions do unfortunately get larger as we keep moving on.